Hello everyone. So today I am going to teach you about the soil modification techniques. Okay. So soil modification techniques will basically arrive for the civil engineering purpose. The civil engineering purpose, so when you try to construct any building or a dam or any type of a structure on the soil, when the soil is not capable of taking a huge load depending upon the structure, in such cases we go for the soil modification techniques. Okay. The soil modification, there are many type of soil modification techniques. For example, so we have a mechanical modification techniques, hydraulic modification techniques, chemical modification techniques, and the thermal modification techniques for the soils. So the modification techniques basically increases the capacity, the load carrying capacity of the soil than the natural load carrying capacity of the soil. So in this regard, so in today's lecture, so I am going to explain you about the mechanical modification technique of the soil. So first, let me define what is mechanical modification technique of a soil. The mechanical modification technique of a soil is nothing but the increasing the load bearing capacity or the strength parameters of the soil by applying the mechanical force. Such as the mechanical force can be anything which is applied externally to the soil to increase the load carrying capacity of the soil. Okay. So in other words, so there are other type of techniques as I mentioned. There is the other one is the chemical modification technique, which is accomplished by adding certain chemicals to the soil which increases the strength parameters of the soil. Similarly, the hydraulic techniques, the hydraulic method of increasing the strength of the soil is by removing the excess water which is present in the soil. The final one is the thermal modification technique. So whereas the thermal modification technique is done by supplying the excess of heat in the soil, whereas in the case of heating technique, and in the case of the cooling technique, we freeze the soil, we freeze the water which is present in the soil, and by then which increases the strength of the soil. And these are all the various modification techniques that are basically done to increase the strength of the soil. Okay. So now coming back to our actual topic of discussion today, so which is the mechanical modification of the soil. So as I mentioned earlier, the mechanical modification technique of the soil is done by applying external force to the soil. Okay, so that the soil strength will be increased. And this can be done by two processes, which is called as the compaction, and another process is called as the consolidation. Okay. The compaction and the consolidation, in both the process we are applying the force externally, so to increase the strength of the soil. Now let us discuss how exactly the compaction and consolidation is going to increase the soil strength. So you must be familiar with this diagram. So this is the soil three-phase diagram, so which has the soil, a water, and an air content. Okay, so which is a typical the soil three-phase diagram where it has contained the three phases: soil, water, and air. So during compaction, what would happen is, so when you apply an external force, so due to application of external force, the soil air will be removed. So soil air will be removed, and then the soil compaction will be taken place. So whereas in the case of the consolidation, the water will be removed from the soil, whereas the air and the soil particles remains as it is, which increases the strength of the soil. Okay, so let us compare these two phenomena, because these two phenomena will come under the mechanical modification technique. So let us compare these two phenomena, how exactly it works, and in what situation we use compaction, and in what situation we use the consolidation process. Okay. The compaction process. The compaction process is done on the soil. So after the compaction, we remove the air voids from the soil. But whereas the water content and the soil particles will remain as it is before compaction and after compaction in the soil. Okay. And whereas in the consolidation process, only the water will be removed out, and whereas the air and soil particles remove as it is within the soil mass. So that's the main difference between the compaction and consolidation process. And the second and the most very important parameter for the compaction and consolidation is the soil condition. the soil has to be partially saturated in order to do the compaction process. So whereas in the process of consolidation, the soil must be completely saturated. That is must. So I mean to say the soil should be completely saturated in the case of consolidation process. So the consolidation cannot be done on partially saturated soil. The consolidation is done on only completely saturated soil. So whereas the compaction is done only on partially saturated soil, which removes excess air from the soil particles. And then the third and very important parameter is the process time. So how much time would take the compaction and how much time would take the consolidation? As you know, the compaction is compared to consolidation, the compaction is instantaneous process. It can be done within the matter of a few hours. So whereas in the case of consolidation, the consolidation is a time dependent process where it takes years of time to occur the process of consolidation, especially in the case of clay soils. And then the compaction methods. The compaction can be performed either by rolling or damping or by vibration. So any method can be adopted while carrying out the compaction process. And depending upon which, we have numerous equipments that are available. So various equipment that are available to carry out rolling, damping and vibration in the case of compaction of the soil. So whereas in the case of consolidation of the soil, the consolidation phenomena is very simple. Whereas on a saturated soil, we keep a heavy load and we just allow the heavy load to consolidate on its own. So which is nothing but the consolidation process. So where in the consolidation process we don't use any other different type of techniques. Just by placing a heavy load, we carry out the consolidation process. Okay. So after discussing the difference between the compaction and the consolidation, so let me take you through how exactly the compaction is done. So let me take you through both the process separately, the compaction and consolidation. Okay, so let me start with the compaction. So compaction is done basically to improve the soil properties. So basically to improve the soil properties, right? So the application of compaction is extensively used in the case of highway construction, railway construction and embankment construction. Okay, so to use the soil properties in such activities, first we conduct a compaction test in the laboratory, which is called a laboratory compaction test. So the laboratory compaction test is basically done in two methods. So one is the standard Proctor test. So and the second one is called as the modified Proctor test, which is also called as the light compaction and heavy compaction. So the Proctor is the scientist who invented this test. So hence it is named after his name. The test is named after his name. So which is called as the standard Proctor test and the modified Proctor test. The standard Proctor tests are usually conducted in the case of highway constructions and embankment constructions. So whereas the modified Proctor test is conducted for only in the special cases, such as the construction of runways for a heavy aircraft, or in other special cases where the heavy loads are involved in the road construction. In such cases, we conduct the modified Proctor test. Okay. So now let me take you through how exactly these tests are conducted. Okay. So in order to conduct a light compaction test or modified compaction test, so we make use of a steel mold, so which is as follows. So which has the three parts. Okay. So one is a collar, and the second one is a mold, which is the main part of the test, and then the base plate. The mold has a height of the 12.75 centimeter and the diameter of the 10 centimeter. Okay. And in order to conduct this compaction test, so it can be both light compaction or heavy compaction. So we use the soil which is passing through 4.75 mm IS cylinder. Okay. So now let me take you through the light compaction test. So in order to conduct the light compaction test, we need the minimum of 3 kg soil, which is completely oven dried. So woven dried soil, it should not contain any moisture content before starting the test. Okay, and then so take a soil which is completely woven dried in an enamel tray, and then so we mix the water content in terms of percentage. So we start mixing the water from 5%, and then with an increment of so the 3%, 8%, 11%, 14%, and so on. So at every percentage of water, so first mix the water and the soil thoroughly, and then place the soil in the mold. So place the soil in the mold and then compact the soil using the 2.6 kg hammer, and the hammer is which has a facility to drop from a height of 310 mm. And so we have to compact each layer of the soil for about 25 blows. Okay. So after compacting the first layer, then you provide the second layer of the soil in the mold, and then again you repeat the same process. Compact the soil using a 2.6 kg hammer. So dropping the hammer from a height of 310 mm and giving the number of blows of 25. So compact the second layer, and then you place the collar, and then continue the third layer with the same process. So after compacting the 3 layers, so detach the collar from the mold and then trim the soil up to the top surface of the mold, and then measure its weight. So that weight should be recorded. Okay. So repeat the same process by adding the different percentage of water content. And then, so once you complete all the process of repeating with the various water content, you note tabulate the readings. So once you get all the values of weight, so then you calculate the volume of the mold by measuring its diameter and the height. So the volume can be calculated as, since it is a cylindrical mold, pi by 4 into d square multiplied by height. So we'll get the volume. So once we get the volume, so you calculate the bulk density of the soil. The bulk density of the soil is calculated as the weight of soil in the mold over the total volume of the mold. Okay. So similarly, you calculate the bulk density for all the water content and the weight. And then, so after you calculating the bulk density, calculate the dry density of the soil by substituting the value of bulk density and the water content which we added at each strand. Okay. So once you calculate the dry density, you plot the curve which is called as the compaction curve. So in the compaction curve, which is plotted against water content taking along x-axis and the dry density along y-axis. And then, so the curve will be always in such a form that initially it will keep on increases up to a certain point, and then it will decrease. So this trend of increasing and decreasing will be followed mainly because of, so when the water starts adding in the initial stage, from the beginning the water will act like a lubricant in the soil up to a certain point, and once it reaches the certain point, what will happen is the water will start dominating over the soil particles. So water will start dominating over the soil particles, and hence the water will not allow the soil to get compact, and hence then the density of the soil will keep on reduces further. And then, so after you plotting this curve, so you note down the point where you achieve the maximum density and the corresponding water content. And the density corresponding to the maximum peak is called as the maximum dry density, and the corresponding water content is called as optimum moisture content. So these are the parameters which is actually required for the soil to utilize in the field. So once you get the maximum dry density and optimum moisture content, so these maximum dry density and optimum moisture content are actually used in the field for the construction of roads, or it can be used for the construction of embankment. In such construction, these parameters are actually utilized for any soils. Okay. So now, so coming to another parameter which is called as zero air void slab. So this zero air void line will actually an indicative of whether the compaction you have done in the laboratory is accurate or not. If sometimes due to manual error the compaction may not be proper, and that can be indicated or being seen by plotting the zero air void line. And this zero air void line is calculated by substituting by using this equation where the dry density of a soil equal to G gamma W over 1 plus E, where the gamma W is being the unit weight of water. And in case of E is nothing but the air void ratio, so which can be calculated by Wg by SR, where the SR is the degree of saturation. So it is believed that so when the compaction is done, all the air voids has to be replaced with the water voids. It means the soil should be saturated. So hence we assume the degree of saturation value in this case as 1, or in other words in 100%. And then we substitute these values and we calculate the zero air voids line. Okay, so this is about the light compaction test. So similarly, almost the similar process will be followed in the modified Proctor test, or it is also called as heavy compaction test. So in this test, so we use the same soil, that is the soil which is passing through the 4.75 mm IS sieve, and about the 5 kg of soil is required for conducting this test. Okay, so take woven dry the soil which should not contain any moisture in the soil, and then so you follow the same procedure. So add the water content in terms of percentage, like 5%, 8%, 11%, and the increment of 3 or 4, whichever is convenient to you, and it is again depending upon the type of the soil. So add the soil, and then the compaction is done in a little bit different manner. Where in case of heavy compaction test, we make use of 4.9 kg hammer instead of 2.6 kg hammer. And the height of drop of hammer will be the 450 mm instead of 310 mm. And the number of blows will be kept same, that is 25 number of blows. But the number of layers of compaction of the soil will be 5 layers instead of 3 layers. I mean to say, the soil should be compacted in the 5 layers, 1, 2, 3, 4 and 5 layers, and then so later after compaction the excess soil will be trimmed off, and only the soil which is present in the mold will be considered for the weight. Okay, so after compacting the soil in the 5 layers, note down the weight of the soil and note down the water content that you added, and then calculate the bulk density and then dry density, then again the plot the curve. Okay, the main thing you can see the difference like, so between the light compaction and the heavy compaction, it would be something like this, gamma D and the water content. So if you have performed the compaction test on a soil by using the light compaction test, and if you perform the same on the same soil, if you perform heavy compaction test, then it would be something like this, where the maximum dry density of the soil will be more than the light compaction test. Okay, and then OMC of the soil will be less than the light compaction test. This is the OMC of the soil for the light compaction test. So this would be the OMC of the soil for heavy compaction test. So basically it implies that if you apply the more and more energy on the soil, you will yield more and more the strength of the soil.